Hello, my name is Asima Siamekaolule, and today we're going to look at a very interesting topic in your paper F5 of the ACCA. The topic we're going to look at today is decision making. Under uncertainty. And during this lecture, we're going to consider three major things. Number one, we're going to look at your risk on one aspect and your uncertainty on the other. We're just going to get a definition of both and just appreciate the difference between risk and uncertainty. Then after that, we're going to look at something that is known as expected values. We need to know what expected values are, and at the same time we need to be able to calculate an expected value. Then finally we're going to look at other decision rules. Under here, on one aspect you're going to cover what is known as maximax. The other aspect we're going to cover something else known as maximin. And finally, we're going to look at what is known as minimax. Regret. I trust that at the end of the lecture we'll be able to understand all the aspects and be able to calculate whatever is required. We'll look at an example of how to calculate all of them. However, I want you to note that when we're looking at these two aspects over here, we're going to look at something that is known as a payoff table. Or if you want to be fancy with English, you can call it the payoff matrix. It simply helps you calculate and just understand the flow of things when you're calculating your expected values and your other decision rules, which is the maximax, the maximin, and the minimax regret. So now we can kickstart things. The first aspect, as I mentioned, we're going to look at the definition of risk and uncertainty. If you can allow me just to wrap this off. As you can see, the board is a little small. I'm therefore going to have my risk on one side. I'm going to have my uncertainty on the other. What is uncertainty? Uncertainty occurs in a situation where there are several possible outcomes. You have several possible outcomes, however, you are unable to assign probabilities to these outcomes. Risk on the other side, basically the same as uncertainty. You are looking at several possible outcomes as well. So you have your several possible outcomes. However, the major difference between risk and uncertainty is that with risk, you're able to assign, underline that, able to assign probabilities. So what am I saying? With uncertainty, you have several possible outcomes. With risk, you also have several possible outcomes. However, the difference is that with uncertainty, you are unable to assign probabilities to those outcomes. Whereas with risk, you're able to assign probabilities to the outcomes. Therefore, just to give you an example on risk. If you remember the good old days when we used to play a game of dice, or maybe simply even tossing a coin, you will know that your coin will either have heads on one side or tails on the other side. And we both understand when you toss a coin to either land on its heads or its tails. I'm therefore assuming that the coin cannot land on its edge. Therefore, when you toss a coin, there is a 0.5 or simply a 50% chance it will either land on its heads and a 0.5 chance it will land on its tails, giving you a total of 1. Your probability, whatever the case is, should always be equal to 1. Another typical example is if you ever rolled a dice. You will know that a dice has an equal chance of either landing on a 1, or 2, a 3, a 4, a 5, or a 6. Therefore, when you throw a dice, it can either land on a 1, or 2, a 3, or 4, up to 5. Therefore, each element of a dice will have a 1/6. You can even express the probability there as a ratio: 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. Each side of the dice has a 1/6 chance of landing on either side. This should also be equal to your 1 over there. The next part we're going to look at is, as I mentioned earlier, expected values. What is an expected value? This is simply a weighted average, nothing more, nothing less. A weighted average of what? Let me illustrate that using an example. So on this side I'll have my example over here. I think a typical example is maybe to look at F5. If you're trying to look at the chances of you passing, or maybe even failing, let alone getting a prize, you can say, you can have your fail there, you can have your pass, you can have your prize over here. I'm assuming that the fail won't affect you because obviously you're all intelligent students. We can assign probabilities to this. What is the probability of you failing? We can roughly put it at 0.59. What is the probability of you passing? Just as an example, we can put it at 0.40, which is obviously higher than the current pass rate. And what is the probability of you getting a prize? You can have it at 0.1. What is your outcome? The outcome in this case would be what would be the benefit of you either passing or getting a prize, or what would be the disadvantage of you failing in monetary terms. So you can have your US dollar there. Obviously, if you fail, maybe you won't get a job, so therefore, no income for you. What happens when you pass? Say, for instance, you get a job that will pay you 500. And hey, what is the outcome if you get a prize? Maybe you get a job that will pay you 1,000. So what we're simply looking at when you're looking at probability is simply, you're simply multiplying the outcome multiplied by the probability. This is given by the formula known as summation P over X, or rather multiplied by X. While your P is your probability over here, and your X is the value of the outcome, which is the money over here. Therefore, if we multiply those, if I could just grab my calculator over here, if you multiply this by that, obviously you get a 0 over there. If you're going to multiply your 500 multiplied by 0.4, give me 200 over here, and 0.1 multiplied by 1,000 gives me 10. Therefore, you have your 210 there. This is the weighted average. So we've now worked out this. However, what is the interpretation of all this? What meaning do we get out of all this? If you're going to look at this information as a single student, this information might not be very useful to you if you're going to look at individually. As an individual, the only thing that's going to affect you is either you pass you will get a 500. Or maybe if you get a prize, you get a 1,000, a job worth 1,000. However, if you're going to look at it from a bigger perspective, for instance, if I was running a college, the information will be very useful to me because obviously I'm looking at a larger population. Therefore, expected values are useful when you're looking at a larger population.